Hello guys, in this video I'll be finding the current Ix using nodal analysis. To use nodal analysis to solve a question like this, there are three steps involved. The first one is to assign nodal voltages to all the nodes and pick current, the direction of current for all the branches. So assign nodal voltages and what? Branch currents, right? So node 1 here, we're going to be assigning V1, node 2, V2, node 3, V3, and the last node called V0 is grounded, so we have a 0 voltage here, right? Then we need to pick the direction of current for each of the branch that has no current specified. So for this branch between 1 and 2, we already have the current flowing rightward, right? Also for this branch and also for this branch. But the rest of the branch, I'm just going to pick the direction of current. So for 2, 0, assume it's flowing this way, I'll call it I1. For 2, 3, I'm going to pick this direction and I'll call it I3, right? Which other one? And then for this one at the top, I'll pick this direction and call it I4. So the first step in nodal analysis is done. We have nodal voltages with our ground node here, and we have direction for the current in all the branches, right? The second step is to use KCL, KCL, Kirchhoff's current law, to find the sum of current in each of those nodes. Find the sum of current in the nodes. So node 1, we will find all the currents flowing into node 1 with the convention that inward direction is positive and outward is negative. So for node 1, we have 3 amperes flowing in minus Ix minus I4 equal to 0. That is, we have this one flowing in, I4 flowing out, and Ix flowing out. I'll call that equation 1. Node 2, we're going to find the sum also in a similar manner. Ix is flowing into node 2, so we have Ix here. I1 is flowing out, so it's negative I1, and I3 is flowing out, right? Minus I3 equal to 0. I'll call this equation 2. And node 3, right? Which is the last node. We have I3 flowing in. We have I4 flowing in too. But 2Ix flowing out. And all this will give us 0, right? Equation 3. The next step after doing this, which is the third step, is to find the currents, those currents in equation 1, 2, and 3 in terms of the nodal voltages. So if you look at Ix, Ix is flowing from node 1 to node 2, right? It's flowing from a higher potential to a lower potential. So the voltage drop here will be V1 minus V2. So Ix will be, okay, let me just write the step here first. Find the currents, that's all the current in terms of what? In terms of nodal voltages. That's the last step involved. So we'll start with Ix again. It's flowing from higher potential to lower potential. The voltage drop here will be the difference between these two. So Ix is voltage drop across it, which is V1 minus V2, divided by the resistance of that branch, right? Similarly, I4 is flowing from V1 to what? V3. So from higher potential to lower, so I4 is gonna be V1 minus V3 divided by the resistance of the branch again, which is just 4, right? I1 is flowing from 2 to 0, higher potential to lower. So we have I1 is V2 minus V0, which is 0, over the resistance here. And there's one left, I3. And I3 is V2 minus V3 over 8. Having found the individual currents in terms of their nodal voltages, we will just substitute those currents, which I call 4, into 1, 2, and 3. So we'll have substitute 4, equation 4 into 1, 2, and 3, right? Into equation 1, 2, and 3. In equation 1, we have 3 minus Ix minus I4 equal to 0. So we have 3 minus Ix minus I4 equal to 0. We substitute all that V1 minus V2 over 2 minus I4 is V1 minus V4, I mean V3, my bad, V3 over 4 equal to 0, and I'm gonna simplify this. This I can have 3 is equal to V1 minus V2 over 2 plus V1 minus V3 over 4. This will give me V1 into 1 over 2. I'm collecting like terms, 1 over 4 minus V2 over 2 minus V3 over 4 equal to 3. So by simplifying further, we have 3 over 4 V1 minus 1 over 2 V2 minus 1 over 4 V3 equal to 3, right? I'll call this 5. I'll do likewise for equation 2, which says ix minus I1 minus I3 equal to 0. So I'll do the same thing here. Ix minus I1 minus I3 equal to 0, right? So instead of Ix, we have V1 minus V2 over 2 minus I1, which is V2 over 4 minus I3, which is V2 minus V3 over 8. All this will give me 0, right? We'll simplify, collect like terms, V1 into 1 over 2 minus 1 over 4 minus 1 over 8, right? And then V2 will be plus V2. This will give me minus 1 over 2. I must have added the wrong one. No. To simplify, I only have one V1 here. We don't have any V1 anywhere else. So V1, 1 over 2. Then V2 is the one that has all the extra minus 1 over 8, right? And then V3 is gonna be plus V3 1 over 8 because negative negative will give me positive. So I'm gonna simplify further. I would have 1 over 2 V1, right? And this one, this is the same thing as 4 over 8. This is the same thing as 2 over 8. So 4 plus 2 is 6 plus this is gonna give me 7, right? So minus 7 over 8 V2 and then plus 1 over 8 V3. I'll call this, well, this is equal to 0, and I'll call this equation 6. And then the last equation is equation 3, I3 plus I4 minus 2ix. We do the same thing for equation 6. So we have I3 plus I4 minus 2ix is equal to 0, right? So I3 is V2, it is V2 minus V3 over 8, V2 minus V3 over 8. I4 is V1 minus V3 over 4, I believe, and minus 2ix. Ix is V1 minus V2, V1 minus V2 over 2. All this will give me 0, right? So let's see what this will simplify to. So we have V1, I'm going to write all the V1s first. So V1, we have 1 over 4 from here. From here, we have minus 2 over 2. You see that because of this. And then we don't have any other V1. Then we have V2. We have 1 over 8 from here. And here we have minus minus will give me plus 2 over 2, right? And I think that's it for V2. Then V3. We have minus 1 over 8 here. We have minus 1 over 4 here. And that's it. Equal to 0. Let's simplify further. This is 4 over 4 minus this will give me minus 3 over 4 V1. This is 8 over 8. So it will be 9 over 8 V2. This is the same thing as 2 over 8. So this will give me minus 3 over 8 V3 equal to 0, equation 7. So I'm going to bring all those equations together and we'll solve them. So we have, I'm just going to write them in a matrix form, but let me bring them down here. The equations we'll be solving simultaneously are equation 5, 6, and 7. So we have 3 over 4 V1 minus 2 over 3, sorry, 1 over 2, rather. 1 over 2 V2 minus 1 over 4 V3 equal to 3, equation 5, right? And then equation 6 is 1 over 2 V1 minus 7 over 8 V2 plus 1 over 8 V3 equal to 0, equation 6, right? And then the last one is minus 3 over 4 V1 plus 9 over 8 V2 minus 3 over 8 V3 equal to 0, equation 7. We'll be solving them simultaneously, so I'm just going to write it in a matrix form. We have 3 over 4 minus 1 over 2 minus 1 over 4 here, right? And then this one is 1 over 2, equation 6, I mean. 1 over 8, and then the last one is minus 3 over 4, 9 over 8, and minus 3 over 8. We have V1, V2, V3, and then we have 3, 0, 0 here, right? Now, a simple way of solving this is just to use your calculator and find the RREF. Reduce row echelon form of 3 over 4 minus 1 over 2, 1 over 2 minus 7 over 8, 1 over 8, minus 3 over 4, 9 over 8, minus 3 over 8, augmented with the answers here. While we solve this, give me 1 second to solve this. So I'm still solving it. I'm punching all this into my calculator and I'll just do the RREF of this. So after solving this, I got my V1 to be 24 over 5 volts. V2 is 12 over 5 volts, and V3 is minus 12 over 5 volts. Now, if you remember from one of equation 4, we have Ix as V1 minus V2 over 2. Ix is V1 minus V2 over 2. So recall Ix is equal to V1 minus V2 over 2. So we're going to substitute. It's 24 over 5 minus 12 over 5 divided by what? 2. This will give me 12 over 10. And this is, let me see again, this is 12 over 10, which will be 1.2 amps. And this is the end of this question. Thank you for watching.